Yes, sir.
Okay, so good evening all. So we'll start today's discussion. So if you have remember, yesterday we had discussed different measurement scales, isn't it? So what
Yes,
are the
sir.
scales we have discussed? There are four different type of scales. One is ratio in terms of the impedance ratio, then interval, then
Ordinal.
ordinal, then nominal. Okay, nominal. So this order is actually in terms of their characteristics or from highest level of information to lowest level of information. Okay, it means if a variable is in ratio scale, so this gives us better or quality information compared to the other variables which are measured in other scales. Okay, and first two are quantitative data, represents quantitative data. Second, third and fourth, they represents qualitative data. So this is what we had discussed, so I will not repeat again. Okay, so now if you see this question, okay, so what is this question? You can see arrange the following from higher level to lower level of scales of measurement involved in them. Okay, please read the questions. Okay, read these statements. First one is researchers divide the sample in two groups based on area of residence like urban and rural area, and a student has got 50 marks. Second statement, a student has got 50 marks out of 60 marks in English language test. C. A cricketer is given 10th rank as an all-rounder. D. The height of a particular building is double than all other building in a state. We have to choose the correct answer from the option given below. So which one will be the correct answer, you think? Yeah? Any idea? Sangeeta?
Sir, I think option C is ordinal scale. A cricketer is given 10th rank as an all-rounder. So,
Okay.
um,
But okay, let me explain you with the reason. Okay.
hmm,
So actually the answer will be this one, option 4,
D. Hmm,
DBCA.
hmm,
DBCA. You are saying earlier
hmm,
it is 3, CBAD,
hmm,
right?
hmm.
So now
No,
this
no,
is,
sir. I said that C will be in third position, ordinal scale.
okay. Okay, okay, then you are correct. Okay.
Yes, sir.
So now just to remind you what we had discussed and how it is related, just I will tell you quickly. Means how you can attempt this question and so that we can remember what we had discussed yesterday. Okay. So what basically it is happening over here is already you know the answer, but let me explain you. So you have to actually identify the scale of measurement for each one of these statement. Okay, then you have to arrange them from highest to lowest level. Okay, and hierarchy of measurement scale already I had given you: ratio scale, interval scale, ordinal scale, nominal scale. Okay,
Yes, sir.
suppose for example I had written first ratio scale. Okay, so in ratio scale it has true zero, isn't it? It has true
True zero.
zero and equal intervals, meaningful ratios. Yesterday we had discussed, right? And obviously there will be natural ordering. You can write in both ascending or descending. Okay. Second, in interval scale, equal intervals but no true zero. Okay. Equal intervals intervals, but no true zero, no true zero. And obviously ordinal scale, this is about interval scale. In ordinal scale, what was happening? In ordinal scale, it was rank order. Basically, it is ranking. Nominal scale, nominal only categories. Okay. So now let us analyze the statement. Can you just tell me D is which scale?
The height of a particular building is double than ratio scale, sir.
Ratio scale. Why it is ratio scale? Because first of all, it is comparing two values. Okay, height of building is double. It is saying, right? And also, it is meaningfully comparing the ratio, because we had discussed now there are three properties. First, the ratio should be meaningful. Okay, because it is saying the
Yes,
height
sir.
of a particular building is double than all other building in the street, because it is showing a double. It means if that height of a particular building is the other buildings are x, then this building is 2x, right? So it is 2 times.
Yes, sir.
So the ratio is meaningful. Okay, is
Okay.
it clear?
Yes, sir.
So it is ratio scale, and obviously next sentence is, you can say C. C. What is C?
Ordinal scale.
A cricketer is given 10th rank as an all-rounder. So this is ordinal. This is an ordinal scale because it is showing the ranking and order, but the difference between rank is not necessarily equal. Okay. Then B. B is, what is happening? B. B is again
Interval scale.
interval scale, but if you remember, it is again ratio scale, because I told you na. That is why you have to identify. You see, 50 marks are there, right? Marks.
Okay, sir.
Marks means it should be ratio scale. Are you getting my point?
Okay.
So that is why the question is little confusing. Okay. But DB represent the same scale, ratio. This
Okay,
is
okay.
also ratio, and D is also ratio. This is ratio, this is ratio. B and D, both of them are ratios. Okay. Why? Because the property as I had mentioned you. Okay. So when we are saying 50 marks out of 60, so test score have a true zero, isn't it? Means a student can get zero, na? Because ratio scale, one of the properties, the true zero will be meaningful. Yes or no?
Yes, sir.
Are you getting the logic? Why it is interval, like ratio scale is a special case of interval scale, isn't it? Yesterday we did that diagram, na? Okay. Is it clear? That if you just to remind you, ratio scale is a particular case, isn't it? Can you
Yes,
see?
sir.
Ratio scale is a special case of interval scale, where true zero it can contain the true zero values and it will be meaningful. Is it clear?
Yes, sir.
Yes, sir.
So I was just going through June 2025 question paper, so I found this is interesting. And then one more, statement is not actually analyzed. That is urban versus rural. So this is just a nominal scale. Okay, the lowest level of information. Okay, and because there are categories, but there is no inherent order or there is no natural ordering. This urban and rural area. Okay, is it clear, Sangeeta?
Yes, sir. Yes, sir.
So in economics, what it will be called? Urban, rural. They are categorical variable, or they will be called dummy
Hmm.
variable. They will be called
Dummy variable.
dummy variable. Okay, we will be discussing in qualitative regression. Okay, when some of your independent variables will be qualitative in nature. Okay, so that we will discuss. But here it should be only nominal scale, so there is no natural ordering. This shows lowest level of information. So now coming to our answer. So the order is D. You have to write like ratio,
Ratio scale.
B again ratio scale, okay,
Okay,
C
sir.
ordinal, okay, sorry, little messed up. So it is, sorry, 1 second. 1 second. So C will be ordinal, okay, C will be ordinal, C will be ordinal, then A. What will be A? What is A?
Nominal scale.
Nominal scale. Very good, excellent. So, is it clear? So the answer is
Yes, sir.
DVCA. Okay. So I will love to discuss the statistics and econometrics part of June 2025, but I will do it tomorrow. Okay. Because if you see there are questions. Of course, paper 1 we are not going to discuss today. So we'll be discussing the paper 2, right, and section 3, basically the statistics and econometrics questions from June 2025. Is it clear? Yeah.
Yes, sir. Yes,
So,
sir.
so if you will see the question, 1 second, I'll come to some of the questions. I can still discuss, but it will take lot of time. So today we will finish our yesterday discussion, so that we can start fresh again. Okay, this part I'll tell you from where it is starting. Micro Bhaktimam we will discuss, right? And you can see it is starting from here. Question number 59. You get it? Bootstrapping technique is used to what? What will be the answer? Okay, obviously this will be completely a new terminology for you, isn't it? So, yes, Sangeeta? Yes or no? Bootstrapping? You
Yes,
know?
sir.
So what
No,
I'll
no,
do?
sir. I don't
So
know.
what I'll do
Hmm.
is tomorrow I'll solve each one question by question. Okay. But today we'll finish because we had planned that we will gradually finish the theory also. Then we will discuss. Is it fine? Yeah.
Yes, sir.
So this already we have discussed, right? So what I am going straight away, just you have remembered this, right?
Yes, sir.
I hope so. So arithmetic mean is more appropriate for which type of data?
Ratio scale data.
Interval and ratio scale variable and quantitative data. Because I told you this interval and ratio scale, they are part of quantitative data, isn't it?
Yes, sir. Yes, sir.
They shows quantitative data. And this nominal and ordinal, they are qualitative data, isn't it? Qualitative
Yes, sir.
attributes or qualitative data. So obviously in case of nominal, your first preference should be mode. In case of ordinal, it should be median and then mode. Okay, so first preference will be median, and in case of interval and ratio, if your data is quantitative, then first preference will be mean, then median, then mode. Okay, I hope this is clear. So now we'll go to the next level. Okay, so there are couple of things which I want to discuss over here. Okay, so where I will write, let me see if I can write it somewhere. Uh, where I'll write, 1 second. I'll write in a blank document so that I can save it. Okay, there is no need to use the blank document because I think I can use uh, share, stop share, whiteboard. Just to let me know if you are able to see my whiteboard or not. Okay. Is it visible?
Yes, sir.
Okay, great. So, what we had discussed yesterday, measures of central tendency, okay, is largely divided into three parts. One is mean, then median, then mode. Isn't it? Is it visible? Is it visible?
Yes, sir.
Okay. Mean. This is mean. Okay. So again in mean you have, I think you must be knowing, but yes, the trickiest part will come because we are going each section by section. Then this is geometric mean. Then this is harmonic mean. So as an economic student, we know many of them. Like maybe we have studied also, but yes, when we are preparing for exam, so you should know that okay, the questions you should be ready to answer the questions in each of these sections. Okay, so already I think you know what are the properties of a statistical average, so I am not going to discuss that over here. So rather what I will be writing is just I will quickly write arithmetic mean formula. So we write arithmetic mean formula, that is simple m x bar is equal to summation xi upon m. Okay, summation xi upon n. Is it clear? Yes or no?
Yes, sir. Yes, sir.
So I will make it little thinner so that you can read the subscript also. Okay, so summation xi. Okay, if my handwriting is not readable, just let me know. Okay, so this is simple arithmetic mean. Okay, so now the question is, we will not discuss how you can calculate because this is not very difficult. So rather I will say some of the one of the important properties of arithmetic mean, that is summation of xi minus x bar is equal to 0. Okay, it means the algebraic sum of deviation of observation from their m, means arithmetic mean, will be always equal to 0. Is it clear? You can prove it. How this is 0? Sangeeta? Yeah, not a problem. Like if you know, because here you should know the properties of summation. Okay, I'll just quickly do it. What exactly this means? This is a very important property, okay, of arithmetic mean. Summation xi, because already we know x bar is equal to summation xi upon n. So obviously summation xi will be, what exactly it will be, Madhusmita? N into x bar. isn't it?
Yes,
Yes.
sir.
No?
Yes, sir.
So if we will open the bracket, it will be summation xi minus summation x bar equal to 0. So if we will take summation, now already we know summation xi is n x bar, n into x bar. So because this is a constant, so when we add constant n times, so it will be n times constant itself. Okay, so it will be, because we are adding a constant, x bar is a constant over here, so it is n x bar. So plus or minus get cancelled out, so this is 0. So this is a very important property. Okay, because we are going to use this property later on as well. Another thing you should know about the arithmetic mean is it is having a disadvantage that it is highly affected by the extreme values, extreme large and extreme small. Okay, presence of, or you can say arithmetic mean, m is by affected by presence of extreme values. Okay, that is extreme large or small observations. Okay, like we will not do example, so let me see if we can go further. Next page. So you have understood, right, this one?
Yes, sir.
Is there any doubts?
No, sir.
Okay, if you have any doubt you can ask me, or I will simply go to the page number 2. What I will discuss, because I am covering all measures of central tendency in one go, so that you will remember. Okay, Sangeeta?
Okay,
Then
sir.
we'll go to another measures of central tendency is simple GM, that is geometric mean. Okay, so first of all,
Yes.
let me tell you once again, arithmetic mean is, again I am telling you, it is suitable for the interval and ratio scale variables which are of course quantitative data. Okay, but there are disadvantages that it is highly affected by the presence of extreme values. Okay, so now coming back to geometric mean, so basically you know that it is, we find the nth root of the product. Okay, simple GM. So what is simple GM over here? You can say G, small g you can write. So that is, you can write like if x1, x2, there are xn observations are there. So basically you can find out geometric mean by taking the nth root of their product. Like for example, if there are there are 3 numbers, so what will be the geometric mean? Quickly, so it will be 8 into 1. Yes, what it will be, Sangeeta? It will be 8 into 1 into 6.
Into 6.
Then you have to take the cube,
3.
right? Cube basically, root cube. Okay, because 3 numbers are there, right? So it will be
48
48, root cube of 48.
cube.
Okay, so we will not go detail issue like what are the other issues with geometric mean, but I'll just quickly tell you from the exam point of view. Geometric mean is much more difficult to calculate AM, right? But JM is less affected by the presence of extreme values. This is something which you should remember. That is the reason why we will be using geometric mean in the construction of index number. Okay, so this is a very good logic. Are you getting? Okay. First of all, GM is difficult in GM is difficult to calculate. Chinmay, are you there? GM is difficult to calculate than AM, arithmetic mean. So, okay, but what you have remember, GM, geometric mean is, oh sorry, little it is overlapping, I'll just correct it. So it is less affected, it is GM is less affected by presence of extreme values Is it clear?
Yes, sir.
Okay, thank you. So, and it is used, sometimes it is used in the construction of the index number. Okay, so then comes our harmonic mean. Okay, so simple harmonic mean we can calculate like h, which is nothing but n upon summation I, take the value like it is 1 upon xi. Okay, so but harmonic mean is of very limited use, but what you should know for from the exam perspective, like NET or any other exam which you are writing, of course you should remember this, that AM, GM and HM, so your arithmetic mean will be always greater than geometric mean, which will be always greater than harmonic mean. Is it clear?
Yes, sir.
So if you want to cross verify, you can always cross verify. Always your arithmetic mean will be higher than the geometric mean and then harmonic mean. Okay, and you can see that like I think one more question which is also very important over here, like price, as I told you, inflation, where we calculate the growth rate, right? The growth rate we used to calculate by taking geometric mean, right? Is it clear? So this is also another question, because in index number we use actually uh, geometric mean. Is there any other like information which you want to give? Because we are not going to discuss like many other important point, but you should know. Uh, Already I told you what is geometric mean. Then I think I will, uh, I have already discussed why geometric mean is referred to arithmetic mean in the construction of index number, because it is less affected by the presence of extreme values, large or small values. Okay, so and geometric mean also it is likely to be more typical of the changing prices than arithmetic mean or any other average. Okay, so if we'll have any other points we can discuss later on. Now we'll go back to our discussion. So of course median and mode already we know it, okay, where we are going to use. So I think I will go back to our previous, you can say, screen which we are using. Okay, so now is it visible?
Yes, sir.
Okay, so what are the other important measures of dispersion? Let us focus on the dispersion. Okay, measures of central tendency already we have discussed. Okay, so measures of dispersion is also very important from the perspective of not only descriptive statistics, whenever from the research perspective also measures of dispersion is very important. Okay, so if you see, uh, let me see. Okay, so if I write measures of dispersion, please write. Okay. Measures of, little not coming nicely. Let me see. Measures of dispersion. Okay, MOD. So there are two type of measures. One is absolute measures. Absolute measures. Second one is relative measures. Okay. What are the absolute measures of dispersion? They are basically range, means are all absolute measures of dispersion. First one is range. Okay. Then quartile division, QD, quartile division. Then mean deviation, then standard deviation, then standard deviation. So these are absolute measures of dispersion. And relative measures of dispersion, what are they? First is coefficient of variation, coefficient of variation. Then coefficient of quartile division, CQ. Okay. Third one is coefficient of mean deviation, CM. Let's write it down clearly. CB, CQ, and coefficient of variation, coefficient of quartile division, then coefficient of mean deviation. Is it clear? Together?
Yes, sir.
Okay. And first of all, why we have to actually study the dispersion? Because dispersion gives you the idea that the spreadness of the data around the mean of the distribution, or how far the basically dispersion means the variability. Dispersion word means variability. What it means? Variability or variation. It means maybe we are having like in a scenario you might be having two series of observation, but it is, even though they will be having the same mean, but you can say that because the dispersion or the variability might be more or less than one series, so you can say that they are not the same series. Okay, like for example, if I will write, let's say that one series is 30, 32, 36, 38, 39. Another series 4, 19, 36, 53 and 63. If you will add them together, so this will be 175, this will be also 175. But does that mean series 1 and this is series 2? Whether the series 1 and 2 are equal or are they close to each other, Sangeeta?
No, sir.
How we will find out? How we will find out whether these two series are equal or same or not? We have to find out the dispersion. Okay? Because
Yes, sir.
dispersion will give us idea which series is more variable or fluctuation, or which series is more distance or far from their mean value, okay, compared to the other series. Okay, so that is why, because if you will calculate the average, so that is not the sufficient. Okay, sometimes you will have the same mean also, you can cross verify. Okay, so average are not sufficient to reveal all the characteristics of the data. Hence, you need to measure dispersion to have a conclusion regarding which series is more variable. And also, uh, dispersion is basically ideally designed to give a numerical value up to the extent to which individual observations vary from the average value. Okay, is it clear? Is it clear?
Yes, sir.
Okay, thank
Yes,
you.
sir.
Okay, so dispersion is very important because this is going to come every time. You can see over here. So already, as I have already mentioned over here. So range is basically, here it is given, of course, you can see there is a information, the first to 11th. The first student got 2, this is the lowest score, and the highest score is 15. So basically range you can calculate high score minus low score, or you can say uh, maximum value maximum value minus minimum value. So range is the most easiest method to understand, and it is easy to calculate, but it is not actually used because it is having many disadvantages. Okay, so then we'll go to the interquartile range. You can see over here. So interquartile range, because if you divide the data, okay, so Q1, Q2, Q3, right, and so interquartile range is basically the distance between the upper and lower quartile. Okay, so Q3 is the upper quartile, Q1 is the lower quartile. So IQR is basically used for ordinal and non-normal distribution. This is, you should remember. And how you can find the semi-quartile, interquartile range? Q3 minus Q1 divided by Q2. This is also very important. So range already we have discussed. Then quartile deviation also we have discussed. Then next we will be discussing mean deviation. I think mean deviation is not mentioned over here, so I will just quickly tell you what is mean deviation over here. So you can write mean deviation about, let's say, that any arbitrary point A, that is nothing but 1 upon n summation xi minus a. Okay, so this is basically we say mean absolute deviation. Okay, but for simple series you can calculate like this. In place of a you can replace it 1 upon n summation xi minus x bar. Okay, so this is uh, mean deviation. So one of the important property of mean deviation is that it has the minimum value when deviations are taken from median. This is very important. If you are taking mean deviation, suppose if there will be questions, mean deviation from mean and mean deviation from median, which one will be the lower? So you will say mean deviation about the median will be the lower or least in comparison to mean deviation from mean. Is it clear? Yeah,
Yes, sir.
kind of, right? It will be very clear. So now next is standard deviation, right? The standard deviation is very important property because we are going to use it in probability distribution also, and in all major, I think, concepts in statistics we are going to use this. Okay, so what I'll do is I'll be you can say we'll just cover this one variance and then we can stop over here, then we'll continue. Okay, so anyone, whether you can define what is standard deviation, because it is here, it is variance is given written, that is why I am discussing what is standard deviation. We say S, or in short form we write SD, standard deviation. So what is standard deviation? Root,
It is square root of
yeah,
variance.
no, you have to write root mean square, root mean square deviation from mean, deviation from mean, from mean, root mean square deviation from mean. Okay, and how you write standard deviation? You write, this is the Greek letter you use, sigma. Okay, so this is Greek small letter. So see, this sigma is small, Greek small letter. Okay, so uh, what is the formula of sigma standard deviation? So it will be root, already we have defined, so 1 upon n summation xi minus x bar whole square. So what is this? Standard deviation. Okay, and if we square it, then this will be known as S square, that is variance. This is known as variance, or you can write sigma square. Okay, for sample it is written S square, but the notation you can say it will be similar, but you should know what is sigma square. So it is written because you can observe one thing over here. Why it is n minus 1 and why I have written n? Who will tell me? What is n minus 1? What is the difference between n minus 1? In this slide it is given, and when I have written the formula it is 1 upon n. What is the difference? Yes, Madhusudha, quickly. Yeah? Are you there? Sangeeta?
Sir,
Okay, not a problem. If anyone knows, Chinmoy?
No, No, sir.
Okay, not a problem. So what is when I am writing sigma square? So here you can see uh,
Sir, this is the subset of n minus 1.
subset, not subset. It's basically sample. Okay, so sample means basically you lost 1 degree of freedom, isn't it? You have calculated x bar, na? 1 already. If you have n observation, x1, x2, xn, x1, x2 up to xn, are you getting? And already you have calculated x bar. So
Okay.
what is happening over here? If you know x bar and if you know all these observations, so last observation you can easily calculate because already you are given x bar. Okay, so this is the degrees of freedom basically. So you have adjusted 1 degree of freedom because you are calculating from the sample. Is it clear? So it depends. If you are already having all the observation, if you consider that it is a population, so you will consider 1 upon n. Are you getting my point? So rather than adjusting it, if you know that okay, you are having all the information regarding your population, so there is no need to adjust again. So you just will discuss more on this. But right now, what you are supposed to know, you can write sigma square. What I will be writing, you can see. I will be writing the formula for the sigma square is 1 upon n summation xi minus x bar square. So this is already, you have to remember that I am writing small, so there is, you can use it synonymously. Small x is equal to capital X as it is used in this slide. Okay, so there is, you should not get confused that whether small x is the deviation form which is usually uh, written in case of econometrics. So what the formula is straightforward. So it is 1 upon n summation xi minus x bar because this is the uh, variance which we are talking about. The variance is basically standard deviation square. Variance is equal to SD square. SD square. This is little not clear. So variance is equal to SD square. Okay. So it is square. You can say if you will square the standard deviation, you will get variance. Then tomorrow again we will be discussing what are the properties of the standard deviation so that we can complete the discussion and then we can go if all the questions which are related to descriptive statistics in the previous year I will be discussing straight away tomorrow. Okay, so thank you all for your
Thank you, sir.
attention today,
Thank you,
and
sir. Thank you, sir.
I will stop over here. Okay, 1 second. Stop sharing. Then, okay. So we'll